All right, okay, so welcome back here. I'm at a different location. I'm actually at my house making this video, so sorry if I have any interruptions, but we'll try to get through lesson 7.3. Um, you can see the SWOT already written here on my board. Okay, so students will be able to write and evaluate expressions that contain variables. Let's take a look at this though, expressions. Remember that's some math that doesn't have an equals to it, right? It's got numbers, operations, but no equals, okay? New words today are evaluate and variables, okay? Evaluate. Remember I told you we don't solve expressions, we evaluate them. We look at them and we figure out what they're trying to tell us. Like I like say, like we get evaluated all the time. Well, we're going to evaluate some expressions. So we're going to figure out what these expressions are telling us. Okay, fancy word here, would be solve, but we don't have an equal, so we can't do that. So it would say write and solve, but we can't say solve here because they're expressions. So we evaluate expressions, as in like we simplify them enough to get an answer, basically, that contain variables. Some of us should already know what variables are. Okay, there's letter or symbols that represent numbers that you can like swap in and swap out, right? Variables are, they're kind of the unknown until you're told what they are. Now it'll kind of make a little bit more sense once we get going here. Okay, so I'm on page 219. Right, so page 219 of our book, and we're on lesson 7.3, and hopefully you will be able to write and evaluate expressions that contain variables by the end of this lesson, and that will make you successful to do homework 7.3. 7.2 should already be done. Okay, we're cruising here, getting our work done and making sure too that you get all your other homework done. And after the lesson, you do the homework and then you do IXL. 30 minutes, 15 questions, grade 5 content. Okay, make sure you're logging in. All right, well, hopefully God blesses us on this lesson and God opens up our minds for learning and helps us understand what variables are. So let's take a look at what we have here on our workbook. Okay, you'll see over here our new vocabulary words are evaluate and variable. We talked about those in our learning target, so obviously we want to understand what those are. Let's get our first definition right here, variables. Let's read this, okay? The expressions below contain letters, so mainly letters, or variables. A variable, okay, circle that. A variable represents an unknown number. So if you put a variable in there, you're like, what does that variable mean? And if you were to ask me, I'd say, I don't know. You have to evaluate it. You have to figure it out. Or sometimes you're given a variable. So let's take a look at these examples here. We got 1, 2, 3, 4, 5 examples. These should look familiar to you as an expression. These are all expressions because there's numbers and things, but there's no equals, right? So we know that they're expressions with variables. Okay, so take a look. Here's our expression, 3.5 plus x. See this x? Anybody know what x is besides a letter? I don't know what x is. It's unknown. Look, represents an unknown number. We don't know what we're taking. We're taking 3.5 plus something, some unknown number, and we're just going to call it x because we don't know what it is. X is used a lot as a variable. I don't know why. Maybe because things don't start with x, so they just like to put it in there. Take a look at this. This is read as n divided by 0.01 or 100th. So n divided by 100th here. It's an expression because there's no equals, and n is our variable, right? Because does anybody know what n is? I don't. Some number. They use n a lot for it too because n starts the word number. Okay, so they like to use x and n for variables a lot in math. Someone just decided to. All right, take a look at this. Here's an expression. Here's an expression with parentheses. We know an order of operations we should solve in here first, right? But that's not the point today. The point today is, see this p? P is a variable. We don't know what it means. No one's told us what it is. It's just some number minus 2. We take some number minus 2, we get something, and then we take it times 5. Here's t minus 6. What's t? I don't know. Nobody told me yet, but it's a variable. So I'm going to take some number and I'm going to subtract 6. Here's another expression, right? Got a whole bunch of steps. Here's multiplication. I'm going to do that before addition, just like last lesson. I would say 10 times w. I don't know what w is because it's just a variable of an unknown number. 10 times something, and then I'd take that, and then I'd add the 4. Okay? What I did basically there is I would simplify all this if I knew what that was. But you know what? Now we can evaluate some of these because we could figure out maybe what these variables are, or maybe we could be told what they were. So if I told you what that was, then you could solve it, right? If I said w is 3, if I would say w is 3, couldn't we take that 3 and put it in there? So then it'd be 10 times 3, which is 30. 30 plus 4 is 34. Then I could actually do this step, evaluate it. Okay, so here we're putting our learning target together. We're writing our expressions. We're going to evaluate them with a variable. Here we go. To evaluate an expression, substitute or change a value for the variable, like what I did here. I literally swapped out the w and I made it a 3. And then use, don't forget this, order of operations. This never goes away. You always use this from this point forward in math. This isn't like a, hey, we're going to learn it for the lesson. This always occurs from here until the end of the earth. Order of operations always exists. It always has and always will. You have to use order of operations to simplify. So we're going to evaluate it. We're going to understand it. It has variables, and then we get to simplify, not solve. All right, so take a look. Here's an example. So it says evaluate. Some of you guys are going to say, well, what does evaluate mean? I'm showing you. So when we get done with the lesson, you should understand what this word means. You're going to get it on tests in the future. Evaluate, you're going to say, what does that mean? I'm going to say, well, it's kind of like solving, but not, because there's no equals. All right, evaluate 5 times what's inside the parentheses, p minus 2. Here, okay, so here you go. Here's the key. It says for p equals 10. Here's the magic key right here to unlock this, right? If it tells you p is 10, you can literally take the 10 and put it in there. That's what makes that p worth something. Okay, so we'll see what it did. So we had 5 times parentheses p minus 2 equals. Okay, it's not meaning equals, it's just saying is, right? Because I told you there should be no equal sign. But it's just meaning this will be that. Okay, so then look at, they took the p out and they put in 10. Right, they substituted. So then we have 10 minus 2. We do that part first. So 10 minus 2 is indeed 8. We rewrote the 5 times, brought down the 8. Now we can do 5 times 8, which gets us 40. Okay, so we simplified it down to 40. So all this right here, when p is 10, it gives us 40. Okay, don't forget this. Look, it's appeared in 3 out of 3 lessons. 7-1, 7-2, 7-3. It's trying to tell you something, and if it appears in 3 lessons, it must be important. So hopefully you're like, Mr. Block, I already understand this. That's good. Parentheses, multiply and divide left to right, and then add, subtract left to right. These are your steps to be successful. Look at all the things you've done, okay? You know that that's an expression. You know that that's a variable. Okay. You know how to evaluate it now using your steps to simplify. All right. So let's take this one step at a time. All right. So let's try an example here. It says evaluate the expression. Huge vocabulary words here. Probably get something like this on the homework and you might say, Mr. Block, I don't know what it means to evaluate the expression. I'm going to tell you, expression is the letters and numbers. Evaluate just means simplify it. But we evaluate it because we know this piece of information. We know that m equals 10. Okay, thank you math book for giving me that, because otherwise I couldn't solve this problem. So see the m? It's telling you m is 10. You rewrite this. Okay, you have to rewrite this so that you put this right in for m. You need to make sure to do this step. So let's rewrite it. We got some space over here. I'm going to say 10, right, minus 4.7. Okay, so now you have an expression that you can actually simplify. So then you take 10 minus 4.7. Right, so then you could solve, see, I want to say solve. You could simplify this by saying 10 minus 4.7. Okay, go ahead and subtract that. See if you can figure that out. Try it on your own. You can't take 0 minus 7, right? So you got to borrow. All right, so this becomes 0. This becomes 9. Okay. All right, so then 9 minus 7 is 3. And then we have this over here, right? We borrowed. So this still was kind of like a 10 times 6. So this is going to be, well, actually we borrowed, I made a mistake. This doesn't become, that becomes a 9. That's my fault. So 9 minus 4 is 5. There you go. I don't know why I made that a 0 over here. I should have made that a 9. Okay, so 9 minus 5 is 9 minus 4 is 5. Man, I'm making mistakes all over the place. See, it's not easy even for a math teacher. All right, so we have 5.3 though. Okay, so we can simplify it to 5.3. So our answer here is 5.3. Never mind my subtraction issue going on over here, right? Okay, so number 2. Let's take a look over here. We got 5 divided by x, right? 5 divided by x is an expression. We know that x equals 1/3. So that we have to substitute for 1/3. So let's rewrite it. 5 divided by, and we put the x as 1/3. All right, dividing fractions, remember? Keep it, change it, flip it. Okay, and some of you also remember that you have to put 1 under 5 to make it a fraction. So I'm going to keep it, change it, flip it right here. Keep it, change it, flip it. All right, so keep it, change it, flip it. 5 times 3 is 15. 1 times 1 is 1. 15 over 1, right? That's a fraction is a division problem. So we take 15 divided by 1. 15 divided by 1. Anything divided by 1 is itself. So 15 divided by 1 is 15. All right, so this 5 divided by x turned into 5 divided by 1/3. Apply our rules for fractions. Simplifies to 15. Okay? So step by step, you just got to work through these. All right, these are all kind of jammed together here on this worksheet. So if you have to grab like a second piece of paper and work them out, that'd be okay. See how much room we got. But let's give this one a shot. Number 3. All right, so 5 plus n times 4. Oh boy, now we got 2 different things in here, right? We have this addition and we have multiplication. Oh man, and now we have a variable. You know what I'm going to do? I know that n is 3, right? We take that 3 and I'm going to put that in there and rewrite it. Make it this little less confusing. So I had 5 plus 3, because n is 3, times 4. Okay. I have an expression here. I have to ask myself, do I do 5 plus 3? Or do I do 3 times 4? Well, look at your rules up there. Multiply and divide come before add and subtract. So see this? This is my first group I want to work with. I want 3 times 4. Okay? So I have a 5 plus, that stayed the same, and now I put these together, I simplify them. What's 3 times 4? That's 12, right? Okay, so now I have 5 plus 12. And that gets simplified myself down to 17. So this isn't anything really that new. Okay, once you get to these parts, 5 plus 3 times 4, you just recognize order of operations and then do the math. Okay? And I know you guys all know how to multiply and add. Number 4, 1/5 times x for x equals 15. So we could take this 15 and put it in there, right? So the 1/5 times stays the same. So 1/5 times x, which is 15, so I want to put that in there. There you go. So now I'm doing 1/5 times 15. Okay, multiplying fractions, right? So we got to know we have to put this over 1 to make it a fraction. You cannot take a fraction and multiply it by a whole number. So the way to make a whole number into a fraction is put it over 1. Doesn't change the value. Okay. Now we just say 1/5 times 15 over 1. When you multiply fractions, you know you just multiply straight across. So 1 times 15 is 15. 5 times 1 is 5. Okay, I end up with 15 over 5. Some of y'all know this is an improper fraction. If you stopped here, you get part of it right, but you can continue. Just like on the some of the previous problems, like this one. Fraction is a division problem. We took 15 divided by 1. Here, we also have to take 15 divided by 5. We shouldn't leave it like this. Excuse me. So 15 divided by 5 is 3. Okay, so I simplified it down to 3. All right? I have my expressions, I have my variables, I have my rules. I follow those to get myself to simplify. Or evaluate the expression. There you go, I evaluated it. I evaluated this as 3. Okay. Let's take a look at some more. Since I don't have a ton of room, I'm going to cross this one off and that one. Okay, you can cross those off on your book too if you need to make room. Okay, so let's take a look at number 7. A lot of stuff going on here. 10 times, and then we have parentheses, 0.05 plus q, for q equals 1.2. So let's start by pushing out this q and replacing it with 1.2. And I have to rewrite it. Okay, I'm going to rewrite it right above it because now I have room up here. 10 times 0.05 plus, we know what q is. Q is 1.2. 1.2, and that's the end, so I put parentheses. Alright, so that's my new problem right there. Oh, now I have parentheses, so now I know I have to do this part first. So I have to take 0.05 plus 1.2 first, and then I can multiply it by 10. Okay, so I'm going to bring this down here because I know that the 10 times stays the same. Now let's add these together. So let's take 1.2 plus, watch your decimals here, 0.05. See how I lined up my decimals? Okay, make sure you line them up. I can put a little 0 up here to keep my placeholder. So 0 plus 5 is 5. 2 plus 0 is 2. Bring down my decimal in the same row. 1 plus nothing here is 1. So I got this 1.25 or 1 and 25 hundredths from here. And I know I had to take that times 10. Okay, see all the room? A lot of room. Or not a lot of room, I mean. So now we have to take 10 times 1.25. I'm going to do a cheat here. I know whenever you take any number times 10, right? You could just take this decimal and move it 1 to the right. Okay, so actually my simplified answer would be 12.5. Okay, sorry about moving the paper. But I could prove this to you. Okay, so let's take right? We're doing 10 times 1.25. Okay, let's make sure we have this right. So I'm going to do 1.25 up on the top because it's a longer number, and I could do any order I want because it's multiplication, right? I'm going to multiply those. 0 times 5, 0, 0 times 2, 0, 0 times 1, 0. Okay, now I have to deal with the 1. Since the 1's under here, I need my placeholder. And then I say 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. Now I add all that up. Okay, so I have 1250. But the only problem is that I know that the placeholder, the decimal, is 2 spots over, right? 2 there, nothing there, so I have to move this over twice. 1, 2, look at that. 12.5 or 12.50, but the 0 doesn't really matter over here, it's the same. So look at that. So we got it right. Proved it over here. Okay? Alright, so let's see what else we got. Do I have enough room for this one? I probably don't have enough room for that one on our worksheet here. But you'd have to make sure you see this d equals 1.5. You take the 1.5 and put it in here. Okay, and then you'd have to just go left to right. So let's rewrite it at least. 2 3/4 plus 1 1/2 minus 1 1/4 plus 5 1/2. Alright, that's a lot to do. And I don't have a ton of room. But we could literally just go left to right on this. We could take 2 3/4 plus 1 1/2, then subtract 1 1/4, and then add 5 1/2 at the end. Okay. The only problem with all this, right, is you need to make sure that you turn them into improper fractions. And then you have to make sure we all have the same denominator. Okay. So lots of steps with number 8. Okay. If I got time at the end, I'll come back to it. But this would set you up to be successful to solve this problem. Okay. All right. Number 9. Actually, I don't have a ton of room there, so I'm going to cross off 9. I think you guys are kind of getting it with all my examples. Let's do 11 and 12, and then we could come back and solve this problem probably. We'll see. All right, here we go. 54 divided by 3 times v. For v is 3, so I could take this 3, put it in here. So I have 54 divided by 3 times 3. Now check it out. We have division and multiplication. What does our rule say about that? It says you can multiply and divide from left to right. So if you have multiplication and division only, you go left to right. So you start here, 54 divided by 3, and then you get that answer, and then you take it times 3. So you have to take 54 divided by 3. Anybody know that offhand? I don't think I do, so I'm going to actually take 54 divided by 3. How many times does 3 go into 5? Once. 1 times 3 is 3. Subtract, we get 24. How many times does 3 go into 24? Well, that's 8. 8 times 3 is 24. Ooh, look at that. It came out real nice. So I know that 54 divided by 3 is actually 18. So I can put that down, 18. And then I want to multiply that by 3. So 18 times 3. I'm going to have to do that too. 18 times 3. You'll kind of see something here, won't you? If I take a number and divide it by a number, then I multiply it by a number, you should see a pattern here. It's kind of a cool problem. Alright, 8 times 3 is 24. 3 times 1 is 3 plus 54. So I'm right back where I started. Back to 54. Look, I took 54 and divided it by 3. And then I took that number and multiplied it by 3. Well, dividing something by something and then multiplying it by itself again, well, it's going to get you right back where you start. It's kind of like saying if you add 2 and then subtract 2, would be the same, right? So if you divide by a number and then multiply it by a number, you're going to end up right back at the same spot. So 54. It's kind of a fun problem. All right, let's take a look at number 12. It says 6 times 0.01 plus n times 0.1 for n equals 2. That's a lot of craziness, but let's simplify it and break it down so we can actually solve the problem. Okay, so let's first rewrite it with the n back in here. Okay, so let's take 6 times 0.01 plus 2, got the 2 right here, times 0.1. Now here's the issue. We have a multiplication grouping, then we have a multiplication grouping. According to our rules, we do multiplication first, and then we add. So I'm going to group my multipliers, right? So I'm going to group that together. I'm going to group this together, and then lastly, I can add them. Okay, so I'm going to say 6 times 0.01. So I'm going to say 0.01, right, times 6. So 1 times 6 is 6. 6 times 0 is 0. Now I say decimals moved over twice, so I move the decimal over twice. So my first group right here is actually 0.06. Now I want to do this group. So I'm going to say 0.1 times 2. Okay? So 1 times 2 is 2. 2 times 0 is 0. Decimals moved over once, so I move the decimal over once. Okay, there's my new answer for that. Remember adding? And I'm going to add 0.2. So now I'm at least down to here. Now I want to add those together. Okay? I'm going to pull that up here so see what I can get. Okay? So I'm going to say 0.06. And I have to add 0.2. It's 0.2. 0.2 goes here because I want my decimals lined up. I could put a little 0 in here to fill in that gap. 6 plus 0 is 6. 0 plus 2 is 2. Bring down my decimal, and there is my answer, 0.26. Right. As you could tell, the lessons are getting a little bit more complex, but that's okay. All right. The video's already at 28 minutes, so I'm gonna pause. I'm gonna end it there. Okay. I know we didn't get back. Oops, sorry about that. I know I didn't get back to this problem, but that's okay. Now what your goal is to work on homework 7.3. Okay. So here's your homework sheet. All right. So up here, look at that. It says evaluate the expression, just like we did on all of these in your workbook. Okay. So if you ask me, what does it mean to evaluate the expression? You could look back at the lesson or you could look back at that workbook. Okay. You basically have to take this number, right, 1.8, and put it in for m. Rewrite your problem. So this is 1.8 divided by 0.3. Okay, like right here too. Check it out. 120 divided by x times 6. Well, guess what? Your x is 2. So I take the 2 and I put it in here. So this is basically 2 times 6. And then whatever I get here, I'm going to take 120 divided by that number inside of here. Order of operations. Right? And then down here, it's kind of an extension. Okay, it's going to have words. It says Max bought a pair of jeans for $32 and 3 t-shirts for $T. Okay, I'm going to help you get started with number 10 actually. All right, so write an expression for the total amount that Max spent. So I'm going to do this. Max spent, he bought a pair of jeans for $32. So I'm going to write that. So there's $32. and 3 t-shirts for $T. So he bought 3 more shirts, and each shirt cost $T. We don't know how much the shirts cost, apparently. Okay, we would want to take the shirts plus the jeans, right? So I'm going to take the jeans plus, and here comes shirts. We're going to do 3 shirts for $T, right? And isn't that jeans and this shirts? Do you know how I make sure to separate these two? I'm going to go like this. That means that I'm adding the jeans price plus the shirts price. But I don't know how much it is, because all I know is he bought 3 shirts, but I don't know what the price of the shirt was. So that's all I would write. Okay. Now look here. It says if each t-shirt costs $9. Oh, now they gave us the price. So we know the t-shirts cost $9. See, that was a T, how nice they made it for you. So I'm basically saying he still had the $32 for the jeans, right? Don't forget about the jeans. Now he's going to add it to the shirt price. He had 3 shirts, right? For $9 each. $9 shirt, not a bad deal. Now we have to see how much Max spent. We have to do this first because it's in parentheses, and that basically gives you the t-shirt price. Okay? So I want to rewrite it. I say 32 plus, because this doesn't move, this doesn't change. And then I do 3 times 9, which is 27. Now if I add the 32 plus the 27, shouldn't that give me a total cost? Looks like he spent less on shirts than he did for that. That pair of jeans, man, that's expensive. So over here I'm going to say 32 plus 27. Okay, add these together. 2 plus 7 is 9. 3 plus 2, 5. Oh, I'm going to put a label on here. How much did he spend? He spent $59. Because he bought a pair of jeans and 3 shirts, so he spent $59. Hopefully he's got a good job. Okay. That's how you step through that. So see this one down here? Luke is 4 years younger than Zoe. Misha is half Luke's age. Let Z be Zoe's age. You're going to have to really work through this one. This one's a big one because you have subtraction, and then you have half of. This one's going to be tough. Bet you guys wish that I did this one for you. But you're going to write an expression for Luke's age, right? Luke is 4 years younger than Zoe. So who's older first? Well, Zoe's older, right? So you take Zoe's age minus 4. Okay, and here it said let Z be Zoe's age, so maybe you're doing like Z minus 4 or something. Then you write an expression for Misha's age. Misha, right? Misha is half of Luke. Well, you take Luke down here, right? And then you put it into Misha's expression. Then down here, you're basically plugging in the number. You're pretending that Zoe is 16, and you could figure out how old Luke and Misha are, right? If Zoe's 16, right, don't you take away 4 to get Luke? And didn't you say Misha is half of Luke? So if Misha is half of Luke, right, so you're basically taking 16 years old, subtracting 4 to get Luke. You should know what that is. And then she is half of Luke's age. So take half of whatever Luke is, 16 minus 4, and then take half of that. Kind of stepped you through it already. So, all right, that video is going to be 34, 35 minutes long. It's one of your longer ones, but we did a lot. So when you get off a Zoom with me and you go watch this video, I should see you on YouTube for quite a long time watching this video. And then once you get the video done, you should do this worksheet. Okay, and then you're going on IXL. So today's going to be kind of a longer day in math because of this 35-minute video. Homework is probably going to take you a little extra longer to do, probably at least a half hour, and then IXL's half hour. So you're going to put in a good hour and a half to 2 hours of math today. All right. First day was pretty easy. These days are getting longer and longer because of the fact that you got harder problems. Okay. All right. Just because we get off the internet and we're off of Zoom and off of things doesn't mean we don't have work to do today. All right. So make sure you do those things for math. Make sure you have watched this lesson. Your workbook is as full as mine. You do the homework, and then you also do 30 minutes of IXL. Then your math class is done for the day. But you've already done your reading. Don't forget to do your Bible. And don't forget to come back tomorrow for reading class in the morning. All right. Thank you very much. Hope you learned. And one more thing is, I hope that you can write and evaluate expressions that contain variables. There you have it. If you need to watch it again, watch it again.